So once again, good morning and welcome to this landmark DevOps demo session. We'll be looking at the demo session this morning, and we have other related issues that we'll be looking at today, including testimonies and thanksgiving. So that said, I'd like us to pray. As the songwriter has prophesied already, you are placing your hand on this. It is going to work for you. Father, we bless you. We adore you. We give you the glory, Lord. It has pleased you to keep all of us alive, sound and healthy. There are folks in the mortuary, some in the hospitals. Some can't make it to this meeting, Lord. We have made it not because we are better than them. We have made it because of your hand of mercy, your hand of favor, your hand of grace, Lord, that is upon us and that is upon Landmark. Lord, I therefore pray that as we get into this session, be with us, grant us wisdom. Lord, I pray that the delivery of this demo will be received with high level understanding upon everyone that is present there. And I decree that at the end of the session, each and every individual will begin to see themselves, Lord, in the big picture that you have desired to grant to every one of us. Lord, we thank you because we know you're a prayer answering God. And once again, you've answered in the name of Jesus. Amen. Okay, so welcome again to this session. We'll be talking about this DevOps program. For the record, my name is Prof. Simon Lega. And I'm going to be taking you guys on this journey today. I have over 17 years teaching experience, so that's my experience when it comes to teaching, and we'll be looking at how what DevOps is all about and how you can take full advantage of this program, and we'll also understand why is it that every individual is recommended at this time to take advantage of DevOps end-to-end IT automation and maybe other IT related programs. So that's a discussion we'll be looking at today. Now, the big question again is before we look at DevOps end-to-end automation, we'll first of all look at how projects have been managed over time. How have they been able to, manage projects over time? Now, there have been an evolution when it comes to project management. And what has it evolved from? That's what we'll be able to discuss. What has project, evolved from? Now, generally, we are talking about helping companies to do what we call build applications. So what we are going to be looking at, it gets to do with, let me see, what I'm going to summarize as, building applications. Let me make sure I have that on records. Bootcamp sessions. Just a minute. Okay. How to help companies build applications. That's what we'll be discussing this morning. And okay. Now, this is the big question we'll be answering today. Let me just copy this and bring it here. Landmark technologies. My landmarktech.com/join. So if you are yet to register, this is just to help you to take advantage of that while this session is in progress. Now, what are you going to be doing as part of what we'll be presenting today? We'll be looking at how projects have been managed over time. And generally, we are going to look at how projects are developed, how they are tested, how they are built, how they are reviewed and qualified, how they are secured, how they are deployed, how they are managed, how they are maintained, how they are monitored. Okay, like how to build what we call applications. So in all of this discussion, now we are going to look at how it is done the landmark technologies approach, which got to do with automation, but how has it been done over time? And how are some companies managing all of this? Now, the process of developing softwares, testing the softwares, building the softwares, reviewing and qualifying the software. Okay, the process of doing all of this, okay, securing the software, deploying, maintaining, managing, monitoring, okay, softwares or applications. Let me just remove the word containerize there since it's your first softwares, okay, and applications is what we are going to be looking at today. Now, look at something. In the past, we have what we call, now for you to be, that is for you to manage this end-to-end process, we have what we call software development life cycle. Software development life cycle. How is software developed? How do we develop software? And what is the life cycle when it comes to developing software? Okay, now we have had different approaches to be able to achieve this end-to-end process. And what are some of the approaches to take note of? That's what we are going to be able to look at this morning. Now, when it comes to development, okay, we have got what we call the waterfall approach, which is what we are going to be discussing. Waterfall approach. Let's see how this waterfall approach works when it comes to developing application in the software development life cycle. Now, let's assume that we want to build an application. This is landmark. Landmark SS. This represents landmark software solution. Landmark wants to build an application for a client. Who is this client? So therefore we have the software company. Software company. Software company. This is a software company. In this case, Landmark is a software company. Now, Landmark software solution. Landmark has a client, and this client is eBay. So we have eBay as clients. So the client here is eBay. This is Landmark. So we want to see how we can, how eBay's project can be managed using what we call the waterfall approach. Let's look at the waterfall approach to software development lifecycle, SDLC. The waterfall approach to software development lifecycle. This is Landmark confronted by a client, eBay. So eBay comes to Landmark. What happens is that this application needs to be what? Okay, now we need to build an application for eBay. As part of this process, in this approach, waterfall approach, the first thing that is going to take place is that we are going to be able to sit down with eBay. Let me come back here. Sit down with eBay and understand what they want. You see that what is it that it is required by eBay? What do they expect to be done as part of this project. So we have here, so now we are going to gather requirements gathering. So a meeting is going to be held with the eBay, with the client team. So eBay will send some members of their team to sit down with our own, with members of Landmark Software Solution. And as part of this meeting, who are the guys that are going to be involved in this meeting? Okay, now we are going to have our software architect, and team lead, software architect and team lead. Now, they will sit down with eBay and they will gather the requirement. They will understand what eBay expects from Landmark. Now, once these requirements are gathered, what is going to happen next is that now Landmark get back, to, let me come back here. Now, it moves into phase 2. You see that? It's a waterfall approach. Now, in phase 2, now requirements have been gathered. The next thing is that, we are going to come up with a design. So you sit down and design exactly what the client wants. In this designing phase, who are those involved? Now, in this designing phase, we are going to need to do a lot of documentation. So at this point, we'll have what we call high-level documentation. And again, why designing the kind of software or the kind of application that needs to be developed for eBay? One of the things that we need to know is which kind of systems would this application run on? So we have what we call systems requirements. What is required to be able to develop this application for eBay? Now, we have this stage, dealt with. The next thing is that once we have designed the kind of project we want to develop for eBay, we have come up with what we call high-level documentations. What are we going to be able to achieve next? The next thing is what we call implementation. Now, what happens here is that, we are going to have our team of developers, like we are building the software. So here, developers will get to work. And what would they be doing? They will actually be writing the application. Like this is going to involve coding. You see that implementation here will involve coding because, this is the project that we are managing for our client. To be able to, implement this project, now, developers are going to be involved. They'll be writing the code. You see that developers are going to write the code. Now, once the code has been written, the next thing is that, remember that this code is intended to be deployed to the client environment. It's meant for the client. Developers have implemented, they have done implementation, which means that involves coding. That's what developers have done. The next phase of this waterfall approach will get to do with what we call testing. We need to test this application. How do we test the application? You see that? Let's come back here. We are doing testing. This is the approach. Now, the application is going to be tested. Who are those involved in testing? Testers, or what we call our quality assurance team. The QA team will be involved in testing this application. Once the testing is done and everything is good, it takes us to the next phase. And let's see what the next phase is going to be involved. Let me try to get this stuff. Now, it has been tested. The next phase, we need to now take this application to the market. To take this application to the market, What we are going to be doing is what we call deployment. So we are deploying the application. This is the deployment phase. Now, who are those involved when it comes to deploying this application? Generally, we are going to have what we call middleware admin. Middleware admins. So middleware admins are going to be involved with deploying this application or taking the applications to the market. Now look at something. When this application is deployed, does it end there? It doesn't. What happens if something is wrong with this application? So we are going to have a phase called the maintenance phase. Maintenance. So we have the maintenance phase. What do we do with this maintenance phase? You see that? Maintenance phase. So now we want to maintain this application. Now, when it comes to maintaining this application, we are going to have our support team being part of it. If something is wrong, the support team will ensure that this application or the client's application is functioning effectively. So this is how the waterfall approach looks like. Now, what is the problem with such an approach? And why are most companies not recommended to go with the waterfall approach, for example? What is the problem with this approach? Okay, that's what you want to look at. What are some of the lapses of the waterfall approach? You see that? Now, if you go by this waterfall approach, you realize that our resource utilization here is very poor. The way we manage resources. For example, now we have architect here and team lead. You see that? Now, again, who are those involved in the design stage here? High-level documentation. We'll see how team lead are going to be involved here. Architects are going to be involved in this design. You see that? Now, look at something here. When you have this approach in particular, some of the weaknesses of this approach, okay, it includes what we call poor resource utilization. Now, this is a serious constraint. What else do we have? Timing. Which is that timing is equally a serious problem. For example, if you are going to use this approach, right, the use of resources here is very poor. Now, look at something. When developers are writing code, the rest of the team, what are they doing? The QA team, what are they doing? Middleware admins, the support team, architect and team lead, what are they doing? So you realize that when it comes to this approach, it has a, okay, in terms of how resources are used, is very poor. You see that? So with this approach, we have what we call poor resource utilization. And in terms of timing, it takes a very long time. This approach could take maybe, about 3 to 6 months. It takes a very long time. It could take 3 to 6 months before you develop an application for a client. And again, if you develop this application and it fails, you have to go back and start all over again, which therefore implies that, okay, now this is not a very good approach when it comes to doing, okay, delivering projects to clients. Now, let's assume that we have this same project that we are managing for a client. Which other approach can we use for the same project? So we've seen the waterfall approach and the weaknesses of this approach. Let's look at one other approach that we can be able to use. We have the Agile methodology. In Agile, we have something like the Scrum framework. Now, how does the Agile approach work? This is landmark software solution. As we have seen, landmark software solution It's a software company. This is a software company developing software for her client. So the software company here is Landmark Software Solution. We want to use the Agile approach to build applications for a client called eBay. eBay is the client. Now, with the Agile approach or Agile method, okay, now this approach is what most companies are using commonly today. How does this approach work? Now, look at something. We have a client that we are managing. The question is, what do we have as our resource base? Let's check out our resource base. Resources, probably we have developers. Okay, resource base. Let's assume for resources, we have 8 developers. We have 2 QA team, 2 QA members of our team. Probably we have 3 DevOps engineer, DevOps, 3, or no, let me talk about, we have QA team, we have a systems admin, sysadmin, systems admin. You see that? Let's see how this other approach is going to work. And probably we have a Scrum Master. We have a Scrum Master, 1 Scrum Master. Now, we want to look at this approach, how this approach is going to be implemented in real time. Let me come back here. Here's our resource base. You see that? Here's our resource base. So for resources, we have 8 developers, 2 QA, okay, 1 Scrum Master, 2 systems admin. Now, these are the members of our team. So here is our resources. You see that? Let's see how this approach is being deployed. With this approach, if we have a client like eBay, now what happens with this approach is that in delivering this approach, okay, it is now what is used commonly is what we call different production sprint or iteration. Iterations or sprint. Now, this sprint is kind of a production period, which therefore implies that. Now, let's assume we have sprint 1, for example. This is sprint 1. Sprint 1 is going to take 10 working days. Generally, sprint is a development period. So we have sprint 1, we have sprint 2, something like that. Now, 10 working days. 10 working days. We have sprint 3, another 10 working days. Let's see how this approach is going to be implemented. So with this approach, okay, how is software built and delivered to the client? Now, what happens is that we want to develop a software for our client. Now, this approach has what we call iterations. What else does it have? Okay, it also has what we call a lot of meetings. This approach has iterations, it has meetings. You see that? And we're going to see how these meetings work. For example, we have what we call daily stand-up meetings. Daily stand-up meetings. Now, daily stand-up, we have sprint planning. We have sprint planning. We have retrospect. Retrospect meeting. Now, these are examples of meetings that are going to be held as far as this approach is concerned. Now, look at something here, please. Now, we are using this approach. before you start any task for any sprint, because here a sprint is a cycle of development. A sprint is a cycle or is a development period. So a sprint generally lasts for about 2 to 3 weeks. But we want to take a scenario that is commonly used, which is a sprint that lasts for 2 weeks, which is 10 working days. Now look at something. Now, we want to develop software for our client. We realize that for us to develop software for this client, okay, now the first sprint is 10 working days. And for these 10 working days, we are able to develop 8 features. 8 features for this particular client. Now, look at something. So in sprint 1, we sit down and we are developing 8 features. Why are we talking about developing 8 features? Because the development of this number of features largely depends on our resources that are available, the team. Is that so? Resources here or our team. So we have a team that is working to deliver these deliverables. Now, in sprint 1, we evaluate and we decide that we are going to deliver 10 features for our client. Therefore, in the sprint planning meeting, let me come here, sprint planning meeting. Okay, now, in the sprint planning meeting, we decide that in this sprint, 8 features are going to be developed. We get to work. At the end of the sprint, we are able to deliver 8 features. Now look at something. Our expectation was that in sprint 2, we may have to develop another 8 features. But again, we get to sprint 2. 2 developers are on vacation. So we are only able to work on 6 features. You see that? So sprint 2, we can only deliver 6 features. Why? Because what is our team size in sprint 2? In sprint 1, this is the size of our team. Now, in sprint 2, what is the team size? The team size is made up of 6 developers. That is sprint 2. Now, maybe in sprint 3, okay, we have just 7 developers. So in sprint 3, we can only deliver 7 features. You see that? So look at something. This is a sprint. A sprint is an iteration. So we have sprint 1, sprint 2, sprint 3. In the 3rd sprint, what do we have in the 3rd sprint? 7 developers are available. You see that? 7 developers are available. Therefore, in this sprint, we can deliver 7 features. But now look at something. This is the agile approach. It therefore tells you that every 10 working days or every 2 weeks, with this approach, we are able to do what? We are able to deploy, okay, some models of the application to the client. So instead of taking, okay, 3 to 6 months as it was in the waterfall approach, in 10 working days, we can deliver to client as expected. Now, the question is, what could be some of the problems of this approach? But don't forget, this approach has importance because, again, it breaks production into, okay, smaller, manageable units. And development is done using what? Iteration or, okay, sprint. That is what we use. Now, it equally has meetings, like daily stand-up. It has sprint planning meeting. In the sprint planning meeting, what happens in this sprint planning meeting, for example? What happens in the sprint planning meeting? You see that? What happens in this meeting? Now, let me come back here. Let me take the meeting this way. Now, we have sprint planning meeting. What happens with this meeting? We have daily stand-up, sprint planning. Remember, before each sprint starts, there's going to be a plan. What do we need for this sprint? What are we going to be doing? Those are daily stand-up.
Okay, that is a sprint planning meeting. We have daily stand-up meeting. Now, this meeting generally lasts for 15 minutes. Daily stand-up, generally a 15-minute stand-up meeting where members of the team will come together and explain what they did the day before, and if they had any problem, and what they are going to be doing today. That is daily stand-up meetings. Like, my name is Simon. Yesterday, I was tasked to work on the servers. I had to configure them. I did the configuration. I had some permission problems, so I've spoken to the team lead. I'm waiting for him to grant me access. So that's what you're going to be saying in the daily stand-up meeting. Now, did you face any impediments? So I was going to carry out my tasks. I couldn't do it because I never had permissions. Therefore, I had an impediment. That is a daily stand-up meeting. We have a retrospect meeting. At the end of the sprint, okay, members of the team will come and sit down and discuss how the sprint went. What did they do well? What went wrong? How could they have done what they did better? And how can they improve in subsequent sprints? This is the Agile approach. It has importance because of the meetings. It brings a lot of what? Collaboration. But this approach lacks automation. Why? Because if you look at it, if we're going to deliver a number of features, it largely depends on our team velocity. So when it comes to this approach, the team velocity is very high. Those are some of the problems with this approach. Team velocity. Is that team velocity is high. So this is the problem when it comes to the Agile approach, and it lacks automation. So now, let us look at, okay, the approach that sells and why you need to have a mastery when it comes to DevOps end-to-end automation. So we are going to be talking about DevOps end-to-end automation and how it can be deployed and how we deploy it in Landmark with relative ease. Now, look at something here, please. We want to look at the DevOps approach. When we talk about DevOps, remember, we've seen Waterfall. Okay, what else have we seen? We have seen Agile. Now, we want to look at DevOps. Now, this is DevOps. DevOps itself, okay, get to do with two things. DevOps. Okay, so DevOps is you bringing developers or bringing the development and the operation team together. Operations team together. Or bringing DevOps, this is bringing the development and the operations team, okay, to collaborate and work together. This is what DevOps is all about. So it has this keyword, development and operations. Now, look at something. Look at what DevOps brings to the table. With DevOps, okay, what happens again is that we have our tasks that we are trying to manage. In this task, we have our team of developers. Developers are going to be writing the code. So developers are coding. Let's see what happens. So we have developers writing the code. For example, here's a developer. This is John. John is a developer. He's writing the code. Now, let's see what is going to happen. So here is John. Okay. Now, John is writing the code as a developer. Now, look at something. Let's assume that John is writing a code that get to do with, like, get to do with some users. So he's writing users, maybe users login, users users.java. It's a Java code. So this is what John is writing, users.java. Now, John is not working alone. Okay, John is working with other developers. So we also have Dominion. Dominion is working as well. This is Dominion. Maybe Dominion is, okay, writing the code that gets to do with the database. Database, utils. Okay, now this is a code that John is writing. It's a Python code. So it's .py. John is writing this code. Now, who else? These two guys are writing. They are. Now, how can they collaborate with each other? For example, how can Dominion knows what John has done? And how can John knows what Dominion has done? You see that? Now, is it possible for Dominion to email his code to John? Or John to email his codes to Dominion? That is not recommended. You see that? If you attempt that, okay, that might be the end. So there is no way John can email his code to Dominion or Dominion. Let's equally assume that we have John, we have Dominion, okay, and who else do we have? Now, we have John, Dominion, and Ola. Now, this is Ola. Ola is working on deploy, okay, .java. Now, how can they collaborate with each other? In a DevOps environment, this collaboration is very easy. What happens is that we have a tool that they can all use to collaborate with each other. That tool is used for what we call source code management. They are writing the code. How can they collaborate? How can the code be managed? So we have source code management. Okay, source code management. For source code to be managed with ease, we have tools like, Github. GitHub. So GitHub, okay, we currently have a tool that is going to be used to track the version of this code called Git. But apart of GitHub, what else do we have? We have stuff like GitLab. Okay, we have GitLab. We have Bitbucket. Bitbucket. Now, look at something. So there is no way if John sends his code to Dominion via email, John is going to be fired because that is not how it is expected to be done. Remember that. We are working for a project. So what happens is that inside GitHub, okay, now they will create what we call a repository. They will create a repository. A repository is just a storage where they can store their code and access the code. So they will create a repository for eBay. Take note, eBay. So eBay is the client. So the repository is created in GitHub. So eBay repository has been created. Therefore, once this repository is created, okay, now the details of this repository will be shared to John, to Dominion, and to Ola. Now, this will permit, okay, each and every one of them to be able to write code and commit it into that repository. So John can write code and store the code. For now, let me just use the simple word store. But as we go in, as you get used to the program, you realize that, okay, we call this commit. So once they write the code, they will commit the code into this repository. Now, watch and see something, please. This is our source code management platform. Source code, how is our code managed? How do we manage our code? How are we managing our code? We are using, you can use GitLab, Bitbucket, GitHub, okay, and we can use Git. Git is used to track the different versions. So look at something here, please. which I want you guys to take note of. Now, when you have Git, it gives the option where now whatever John is doing, Dominion can visualize it and continue from where John has ended. So with these source code managers, it permits collaboration among developers. So developers can collaborate in real time, which therefore implies that now, work can always be in what we call continuous development. Now, look at something. Developers are writing this code. The main reason for writing the code is because they want to deploy the code to the client. And where is the client? Remember, in this case, our client is eBay. eBay is the client. Okay, this is eBay. eBay is the client, and we are talking about DevOps automation. This is DevOps automation. Let's see how it goes. Now, eBay is the client. Okay, so look at something. This code has been written. It needs to be taken to the client. Now, this is, what are they working on? They are working on an application, because this software is just intended for an application to function. So in the customer's environment, on the client environment, we are going to have what we call an application saver. Okay, application saver. So where the application is going to be running, we call it the application saver. A saver, as you get to understand, is a supercomputer. So this application is intended to run in this application saver. Okay, and as we progress with the course, you will realize that the application saver that we are going to use for this demonstration here is going to be Tomcat. So we have Tomcat application saver. Therefore, this code that has been developed by the developer is intended to be deployed in this application saver. But now, you realize that most of the time, okay, now deploying this code to this application saver does not just work like this, because the format of this code, of the raw code that has been written here, cannot run in the application saver in this manner. So what are we going to do? We need to transform the code into what we call packages that can be deployed, packages that the application saver can understand. So in transforming this code, we'll go through what we call a build phase. So this code is going to be built. So we are going to do, we have a build tool to build this application. Okay, so how do we do a build? What are the build tools that are common, or which will be common in our program? Build tools. Now, build tools include stuff like Marvin. It includes Gradle. It includes Ann. These are examples of build tools. We have Marvin, we have Gradle, we have Ann. Okay, so these are build tools. These are build tools. So when a build is done, because there are other build tools, but you are going to come to realize that the kind of projects we manage generally at Landmark, these projects are Java-based projects. Okay, since they are Java-based projects, these are the build tools that are used for Java project. So now we have this build tool. Once this code is developed, okay, now it comes in here as database ut.java. Okay, now once we do a build with this code, it's going to create artifacts like war artifacts, jar artifacts. Now, these artifacts, war, jar, and ear, these are deployable packages, which means that this package that have been created can now be, okay, taken to the client or can now be deployed to the customer. But look at something. If we deploy this application without testing, it's going to be a problem. Therefore, as part of this process, it is going to do a build, and it will run what we call unit testing. So it will perform unit testing on the code. So this is going to be a build plus test. So it will perform unit testing to make sure that developers have written a good software before it can be deployed to the customer. But this is not still sufficient. Now, look at something. We need to qualify this code. Apart from writing a good software, one of the things we need to check for is whether the developers write their software using best practices, using good coding standards. You see that? So we need to do an analysis. So we are going to analyze this code to check. So we need to do what I call qualify the code. So we have to review and qualify. Review, okay, and qualify the code, or what we call code quality. Code quality analysis. So we need to run code quality analysis. And for us to do all of this, we are going to use a tool called SonarQube. SonarQube. So we are going to be using SonarQube to qualify what developers have done. Review and qualify the code and qualify the software. Say something that the guys did a good job. So once this code quality analysis is run, it's going to be checking, okay, what are we analyzing? The developers adhere to, to our standards. Did they adhere? Did they follow good coding principles? Did they do all of that? If we check and they did that, it means that we can now move these packages to the deployment saver. We can move them to the deployment saver. If we can qualify the code, or if the code can be qualified, then we are now ready for deployment. But look at something. We work in a secured environment. What happened if in the process of deploying this application, something went wrong? While you are trying to deploy the application, right now, in the process of deploying the application, okay, there is a failure. There is a failure. The build server fails completely. You want to deploy this application. You want to move these WAR packages, like, okay, like for example, let me illustrate something here. You can have something like application.war. You want to move this application to your application server in your customer environment, and it fails. And this entire, okay, build server goes down. Now, you don't have your package because now there was a problem in transit. You see that? There was a problem in, it's just like, look at something, please. Look at something. If you realize today, most homes, okay, like particularly in Africa, for example, right, most homes, now, if you have water, let's assume you have a water company. Now, this is a water company, okay, water supply, supplying water. This water is being supplied to your home via a pipe. You see that? You have a pipe that is going to be supplying water. Now, what happens if something goes wrong when water is getting to the home? You know what I'm saying? So you want to supply water. Okay, but before it gets to its destination, there is, okay, maybe, roadworks are going on. There are roadworks. You see that? Before this water even gets to its destination, there is a failure. Okay, so this is water. I just want to illustrate something here. Water supply. Okay, you are supplying water. Now, before it gets to the customer's home, there is a failure. There is, the pipe has burst or something has gone wrong. You see that? What is going to happen at home now? You don't have any water. So is there any security measure you could have implemented? Is there anything you should have done to avoid such a failure? Is it possible that you did something that could have avoided that failure? The answer is yes. So let's assume that at home, you have a water tank at home. So at home, you have a backup. So now you have a backup tank. So this is a backup tank. Now, if you can't get water from home, where can you pull water from? If you cannot pull water from home, you can pull water from the backup. So similarly in application, look at what we are going to do here. Let me show you something. This is just an illustration. Now, similarly, once everything has been tested and approved, before the application is deployed to the client, this is what we are going to do. We are going to create a backup for this application. And that backup is what we are going to call an artifact or an artifactory. And what are examples of artifactory to what? Now, examples include Nexus. It includes JFrog. These are artifactories. These are softwares. So now, therefore, with Nexus, what am I going to do? I'm going to upload my artifacts, which are WAR. It can be WAR, it can be EAR, it can be JAR, or other kinds of artifacts. Now, what are we going to do? We are going to back up these artifacts here. Once it is backed up, then we know that if there was a problem, if you were trying to deploy and you were pulling your artifacts from this Marvin bill saver and something went wrong and you have a backup, will you be worried? Will you be worried? You will not be worried. If you have a backup, what are you going to do? You will just pull the artifact, from the artifactory where it has been backed up. So you need to set up a highly secured environment. But look at something. All of these tools cannot work alone. And that is what makes DevOps so powerful. So what are we going to do? We have a tool that we are going to use to connect all of these tools together. And that tool is called CI/CD automation tool. So we have here Jenkins. Please watch carefully. This is Jenkins. Jenkins is used for CI/CD automation. So if you're trying to automate stuff, what should you use? Go for Jenkins. This is Jenkins. Jenkins is going to be a very powerful tool for CI/CD automation. Now look at what Jenkins will do. Please watch and see something. Because this is where the money is. This is why our engineers are making, 700,000, $500,000 a year and more. Now look at something. Because of this tool called Jenkins, you can connect Jenkins, with your source code management. Therefore, immediately developers commit the code. Look at something. So developers write code and they commit the code, to Jenkins. So now this is phase one. Phase one. So in the first phase, developers are writing and committing the code to the source code management. Once they commit the code here to GitHub or Bitbucket or GitLab, for example, what happens is that Jenkins, Jenkins is going to pull the code. So Jenkins is going to pull the code. And what will Jenkins do? After pulling the code, now look at something. Jenkins have pulled the code. Now, Jenkins will immediately connect with this guy. Jenkins will connect with Marvin. This is Marvin. And what will Jenkins be doing with this guy? He's going to test, okay, and build. Stage 3, we have test plus build. So it's going to run unit testing and it's going to do a build. This is what is happening here. Now, look at something. Therefore, this build tool here is going to make sure that developers did a good job. It will perform some unit testing and it will do a build. Building here means it will create these artifacts. Artifacts are deployable packages, packages that can be deployed in the application server, packages that the application server can understand, that the application server can process. So now, this is step 2. Now, step 3, we need to qualify the code. We need to qualify the software. We need to do a review. We need to analyze. We need to perform code quality at this time. So what are we doing here? This is the next stage, stage 4. We are doing code quality or code review. Which is a code quality review. This is what happened in the 4th stage. Now, once it is reviewed and approved, what are we going to do? We now need to deploy this application. Sorry, we need to make sure that we create a backup because our environment is secured. So we are creating a backup in this Artifactory. So this is stage 5. So stage 5, what do? We upload artifacts. Upload artifacts. Upload artifacts. This is stage 5. So artifacts are uploaded in stage 5. And what happened in stage 6? Stage 6, we are deploying the application now because our environment is secured. So Jenkins will integrate with this guy and do a deployment. Now, look at what Jenkins does. Jenkins is going to connect with the deployment server. This is what Jenkins is going to do. So Jenkins is doing a deployment. Okay. So now Jenkins is now deploying in our app servers. So now this is stage 7. 7, deploy. Now look at something. I want you guys to look at something carefully. This is 7. We want to deploy in the client's application server, email app server. This is deployment. But look at something, please. In real time, the customer will not have only a single app server because, tell me, if you are running your application on one app server, if that app server goes down, what happens to the client? Now, you remember, application is taking what? That is, deployment is doing what? Deployment is taking the application to the market. It's taking the product to the market. Okay, look at something here. Did I miss? I have 2, 3, 4, 5. Now, here is 6. 6. Now, look at something. If we have just a single application server, this is a high risk because it will culminate to what we call a single point of failure. So what are we going to do? We are going to have multiple application servers, like application server 2, okay, application server 1, something like this. So we have multiple application servers, application server 3. You see that? Multiple app servers. Since we have multiple application servers, for us to manage the deployment to all of these multiple app servers, okay, we are going to introduce another tool, another automation tool. And this automation tool, which we are going to introduce, okay, is what we call Ansible. So we can introduce Ansible or Urban Code Deploy. These are tools that are common. Now, we have Ansible or we have Urban Code Deploy. We can introduce a tool like this, and let's see how this tool is going to work. So in this case, now look at something, please. In this case, what happens is that, okay, what will happen here is, now the artifacts are going to be shipped into Ansible by Jenkins. So Jenkins ship the artifacts. So we have something like this. So Jenkins is going to ship the artifacts into Ansible. And with Ansible, with this tool, we can deploy to even 100 app servers at once. So this is a very powerful automation tool. Okay, so this guy can deploy to 100 or any number of app servers at once. That's how powerful this guy is. And that's why we have to introduce it as part of our CI/CD automation. You see that we have something like this. Now, look at something here, please. So this is Ansible. We have deployed our application in a highly secured environment. Now, but the question is, what happens if there is a problem? Now, for us to accommodate how to fix a problem, we are going to make use of what we call monitoring tools. We need to monitor this application. Monitoring. How can we monitor? You see that? Monitoring. What can we use for monitoring? For monitoring, we are going to use stuff like New Relic. New Relic. We also have App Dynamics. App Dynamics. What else can we use for monitoring? We have a good number of tools that are common. Okay, we are going to look at Prometheus. Prometheus. And Grafana. This is monitoring. We also have stuff like Nagios. Now, look at something, please. This is monitoring. I want you to observe something. If something goes wrong with the application, now this monitoring tool, because it is practically impossible for you to be checking the application servers every minute. So if something, now this monitoring tool will be monitoring these application servers. It's going to be monitoring them. So if something goes wrong, okay, the monitoring tool is going to generate what we call an alert. And the monitoring tool, once this alert is generated, it is going to notify the support team. So the support team will be notified. And what is going to be the function of the support team? Now, look at something. If something is wrong, okay, now the support team will be involved. Once the support team is involved, let me show you something. Now, we are going to now have what we call ticketing. We have ticketing. A ticket is going to be created. So there is a problem, a ticket will be created using softwares like ServiceNow, or we have Jira. Let me start with Jira. We have ServiceNow. These are softwares. So a ticket is going to be created. Now, look at something. This is a support team. Once a ticket is created, who is going to be, okay, so this is now, yeah, who is going to resolve that ticket? Who will resolve the ticket? Look at something. Here is our team. Okay, we have a team in our environment. We have a team. You see that? So, what is the team that we have in our environment? We have the development team. We have the development team made up of developers. We have the development team made up of developers. What else do we have? Okay, now we have the DevOps team also. We have DevOps. Now, look at something here. Or we have the operation teams, the operations. The operation team, okay, which have DevOps engineers and others. Think about that. DevOps engineers and others. Now, this is the DevOps team. Let's see what is going to happen. Now, a ticket is being generated. Now, let's assume that if the ticket that is being generated is a ticket that gets to do with the application, okay, who is going to be tasked to resolve that ticket? Which team should resolve the ticket? Now, if we have an application-related issue, so we have apps issues or software issues. Something is wrong with the software. Okay, software / apps related issues. Now, if we have something that gets to do with the software or the application, that ticket is going to be forwarded to which team? It's going to be forwarded to the development team. Development team will be tasked to resolve what? Application-related issues. How about issues that get to do with like the systems, like maybe, okay, so we have operations team. What do we expect them to do? Like DevOps engineers now, if we have stuff that got to do with like maybe our infrastructure. Now, if we have infrastructure issues, okay, we are going to contact this team. For example, now your Jenkins server is down. Your pipeline is not working. The ticket is going to be sent to this team. Please, this is DevOps end-to-end automation, but watch and see something which makes it even more interesting. Now, with what you see here, okay, now, you can be able to deploy multiple applications every day. Whereas, we realize that with the Agile approach, it will take us 10 working days to deploy. With this other approach, Waterfall approach, it takes us from 3 to 6 months. And if there is a problem, it can take up to a year. So look at the different approaches. But what is very interesting here, as you can see, with the DevOps approach, we can deploy like 10 applications in a day. Team velocity is not an issue because we are going to set up a pipeline that once developers write their code and commit it to GitHub, immediately this end-to-end pipeline is going to run. But let me show you guys something which is very, very important. Now, what do we expect developers to put inside GitHub? Now, developers, okay, in GitHub, they are going to commit the source code. The source code. They will commit what we call the source code. What else will they commit? They will commit the build script. Okay, now, remember that we need to perform unit test cases. And they will also commit the unit test cases. So it is the function of developers to commit the source code, the build script, and the unit test cases. Take note. This is what happens in real time. This is DevOps end-to-end automation. This is what we are going to be doing throughout this course. So when it comes to DevOps end-to-end automation, this is what we are talking about. Very important. So again, what did we say summarily? We said that when it comes to DevOps, what are we trying to achieve? As a DevOps engineer, okay, working with my team, okay, what do we do? Working with my team, we, number one, developed. What else do we do? We test, we build, we review, we secure, we deploy, we maintain, we manage, and monitor, okay, software and applications. This is what we do. Now, we develop, test, build, review, and qualify, okay, secure, deploy, maintain, manage, and monitor softwares and application in using what? What do we use? Using automation. Using automation. That's what we use. Very important. Very, very important. Now, look at something. There is a big question that we have to answer. Now, how are applications written? How do we write applications? Or how can applications be written? Now, look at something. Generally, we have what? Now, applications can be written using, okay, what we call a monolithic or a microservice architecture. So what do we have? We have monolithic and we have microservice architecture. And I'm going to explain this because it's important to take note of now. So when it comes to you building applications, it can either follow a monolithic architecture or a microservice architecture. So this is how applications are architected. Either it goes through this kind of structure or, for example, now we are working for an application for eBay application. This application have different modules. You see that? eBay application. So we have our eBay web application. Okay, now the eBay web application got modules. Which are the modules to take note of? Different modules. For example, it has like users module, okay, login module. It has a payment module. You see that? It has a cart module. It has an order module. You see that? So now, these are the modules that are available for this application. Now, look at something. We can decide to architect your application such that the users, the login, the payment, the cart, and ordering, okay, online ordering, all of these are coupled together. Now, if our applications, okay, if we have one module that comprises all of this, it means that you are managing what we call a monolithic application, such that my eBay app, okay, my eBay app is running with a single module. That single module include what? Single module include users plus login, okay, plus payment, plus creating a cart, plus ordering. Like eBay, you can do an online. Now, if you have this kind of architecture in application management, it means that you are managing a monolithic system. But if we decide to separate these models, which is what is recommended, then it's going to fall, so which therefore implies we are going to have different modules for what? Okay, we are going to have module 1 for users, module 2 for login, module 3 for payment, module 4 for creating a cart, module 5, okay, for ordering, you have, okay, for placing an order. Why is this microservices, okay, what is common today? This is common because if you go for this approach, monolithic, right? If there is a problem with your user model, what are you going to do? You will need to, okay, you will need to edit the entire code. And this entire code, which means if there was a problem with users, you have to work on users, login, payment, card, and other. But if you are using a microservice system, okay, if you use a microservice architecture, if there is a problem with user module, you just go to the user module and fix it, and you are good to go. So this is a microservice, okay, system. Now, when we talk about a monolithic architecture, it is going to follow the diagram we have illustrated here, this diagram. Now, if we're going to work using microservices, let me show you what is going to change. So I'll copy this diagram. We are working with microservices. Let's see what is going to change. So I've copied the diagram. Now, with microservices, okay, instead of just deploying to what we saw there called Tomcat, we are going to make use of what we call Docker plus Kubernetes. So Docker and Kubernetes will now be part of our pipeline. Docker and Kubernetes. This is how the deployment will be managed using Docker and Kubernetes. Therefore, in deployment, we'll have something like this. We will not be deploying directly to this application Tomcat servers. What are we going to use? Here, where you see Ansible, okay, we will not be using this guy. We are going to have Docker. You see that? We are going to have here Docker. Okay. So Docker is going to be part of the pipeline. Docker and what? Kubernetes. Kubernetes, that's K8S. Kubernetes. Something like this. This is Docker and Kubernetes. So if you use Docker and Kubernetes, we are going to equally have one other component like Docker Hub, which is an image registry. This is what is going to be involved. And which therefore implies that with Docker, let me even separate this guy. So I can separate Docker. Okay, let me take out this app servers here. So now, here's here our client. Okay, here's here our client. Here's our client. So we have here Docker and Kubernetes. Let's see how this is going to work with relative ease. So let me say this is Docker. Now this is Docker, and here we have Kubernetes. We have Docker Hub somewhere here, and we are going to be deploying inside Kubernetes. Let me just illustrate something. Docker Hub, copy. Docker Hub is somewhere in the sky. We are going to look at all of this. This is Docker Hub. So here we have Docker Hub as our image registry. Docker Hub is in the cloud. It's just like, now this is Docker Hub. So what happens here is that we are going to deploy our application inside a Kubernetes cluster. Okay, this is highly scalable and it's very good for microservice application. So Docker is going to do what we call, it will create an image. Once it does that, it will push the image to Docker Hub. It will push the image to Docker Hub. So this is image is created. So we have here Docker push. This is Docker push. So it will create the image and push the image to Docker Hub, something like that. So it pushed the image to Docker push. So here, Docker is doing what we call build image. So it build the image, push the image to Docker Hub, and Kubernetes, that's where we are going to be deploying the application, something like this. So this is the end-to-end DevOps demo. So the application is deployed. So this now, Kubernetes is going to pull the image and deploy the application. So it pulls image, okay? And so here, this is deployment. Kubernetes is all about what? Deployment. This is where deployment is now taking place inside this Kubernetes cluster. And once the application is deployed, we still have to do monitoring. If there's any problem, so this is, okay, the second scenario. This is very good for a microservice architecture. So please take note, it's very important. So we have something like this. This is the client. This is the client. So this is the end-to-end automation. So now, what is the syllabus? What are we going to be covering in this course? What are we going to be covering in this course in terms of syllabus? That's one of the few things I would like to illustrate at this time. What are we going to be covering in terms of syllabus? Now, exactly what you've seen today, that's what we are going to cover. And we are going to have series of projects, like projects that deals with the end-to-end DevOps automation. By what you've seen today, we are going to go through it, okay, in bits. So as part of this class, we are going to start with Linux commands. So please take note, this is the link for you to register, mylandmarktech.com/join. If you are not yet enrolled for the class, that link is right there. So let me show you how. Let me first of all add this link. Let me add it to the chat box so that, okay, that's very good. The admins have added it to the chat box. So now, this is what we are going to be covering as syllabus for this course. Linux commands, bash shell scripting. This too is 45 hours. Because now, this diagram you see here, all of this stuff is going to be running on mostly on Linux operating systems. So if you have to run on Linux operating system, you see that it means you need to understand Linux commands. Like, you have to create some Linux servers and all of that. So as part of our syllabus, we'll be covering Linux commands and bash shell scripting for 45 hours. The next stop is Git and GitHub for 12 hours. We'll talk about Bitbucket. We'll move to Maven. Okay, we'll equally look at JBoss and HTTP servers. We look at SonarQube, Nexus. Then we get to Jenkins. Jenkins is going to be this number of hours. Why? Because as you can see here, Jenkins get to do with what? Automation. This guy introduces automation. Docker does the same. Now, let's look at what else do we have in terms of what we'll be covering. We also have Docker, 21 hours. Kubernetes, 39 hours. Ansible, 9 hours. AWS Web Services, 21 hours. GCP, okay, monitoring. This monitoring here will include stuff like Prometheus and Grafana, New Relic, okay, Elasticsearch, Firebase, and Kibana. That will cover like, 6 to 12 hours. Terraform, 18 hours. Now, in addition to this, what else do we have? We have interview preparations and resume lines. So all of this is going to be covered as part of this deployment for this program. And that's why we have some common interview questions, or some common question and answers. Let me go to that question and answer. Some of you may not have had the opportunity to look at it now. Landmark technology. These are useful contacts. Useful contacts. Who can study Landmark DevOps e-degree master program? Anyone who have graduated from high school. If you have graduated from high school, you can take the course. And recommendation is you need to be 18 years or older. Now, when is the next class starting? Class 30 starts from today, which is October 8th to February 21st, 2023. And this is the timetable. Thursday, Saturdays, and Sunday. Our next class is going to be on Saturday, it's going to be on Thursday next week. Normally, after the demo, there's no class the next day, which is Sunday. So tomorrow, Sunday, there will be no class. Our next class will be on Thursday next week. So tomorrow will be for you to, finalize your registration if you are yet to do that. Now, therefore, if the next class is going to be on Thursday next week, the 13th, it means the date here is going to be from the 13th to the 21st. Now, people have asked us questions like, I don't have an IT background. Can I still do this course and succeed? The capital answer is yes, because so far we take you from zero IT background to become a highly skilled and professional IT and DevOps engineer. As a matter of fact, over 95% of our graduates working today have no prior IT background before joining. Now, what is the average salary of landmark trained engineers or DevOps engineers? Today, the average salary is about $150 for a single job. And the highest paid landmark engineer is making over $700,000 a year. As a matter of fact, we have somebody making $800,000 plus a year who was trained by Landmark. But what is the good news? You can start making millions of dollars via coaching program that helps engineers start their own companies. Which kind of jobs can I do after completing the Landmark DevOps Master Program? Now, the first is a DevOps engineer. The second is DevSecOps engineer, which means you'll be the person that can also advise and implement security solutions to your company. The third, you can work as a cloud engineer or AWS cloud engineer, platform engineer, infrastructure engineer, Kubernetes engineer, IT recruiter, project manager, Scrum Master, build and release, and site reliability engineer. As a result of the number of jobs you can have, I can humbly submit to you that the outcome of this course is for you to have either one of these jobs or more of them. That is the output once you go through the program. How much is the fee? And can I pay in installment? The fee is $3,600 US and can be paid in minimum installments of $700 per month. But your first installment is supposed to be $800. Now, but what is the best option for you? Your joker is to pay all your fee up front so that you can concentrate on your studies. Please use your name with class 30 as payment reference, message, and screenshot, and send screenshot after each payment. You have to always do that. How can I pay my fee? Very simple. Pay using Interact, Zelle, Cash App, or PayPal. And this is the payment email, payment@mylandmarktech.com. Now, this is when class 31 is going to start, January 7th. What is the duration of this course? The duration of the course is a 4 months program. This is the duration. It's a 4 months course. As you can see here, it's a 4 months course. Which kind of computer will I need for the course? A computer with at least 8 gig of RAM, 500 gig hard drive, and 14-inch screen size is recommended to start. What are some of the course bonuses? Now, apart of the fact that you are going to be taught over 19 modules, we have a boot camp. As a matter of fact, I think Landmark is the only school that run the kind of exhaustive boot camp that is, which we have. We've had our engineers that have gone to other places come to tell us that the boot camp in Landmark is compared to none. So we have what we call boot camp, which includes helping you to get your resume set up, to set up a proper LinkedIn profile, and interview reviews. Now, we provide both academic and work references, daily interview review sessions, 100% job guarantee. That has become 100% jobs guarantee because we have engineers with multiple jobs. And most importantly, the grace of God at work in Landmark Technologies. What is the good news? Landmark 100% job guarantee DevOps EDV Master Program with AWS Linux have trained and have people finish from backgrounds including university professors, pharmacists, CPAs, ACCAs, CFAs, lawyers, accountants, bankers, entrepreneurs, nurses, RN, CNAs, drivers, Scrum Master, factory workers, PSW, DSW students, among others. So these are useful questions to take note of. So please take note. So at this time, okay, this is what we call the DevOps end-to-end demo. So we are going to have a break now. I think I've answered all the questions because the question that we have shared, okay, and that the link for the question has also been sent to you guys. Those are the generic questions that are commonly asked by engineers. Yeah, I see one hand up. Let me just take Mayor. Mayor, can you ask your question?
Thank you, Prof, for taking us through what you've done this morning. It's quite extensive. My question is very simple. What system would you recommend? Preferably, would you say we should go with our Apple laptops, or we should all just try to, as much as possible, get?
Okay, that's a good question. You should.
Thank you.
The first preference for systems is a Windows laptop. Have a Windows laptop. But if you already have an Apple laptop, that's okay. You can use an Apple laptop as well. But the first preference is a Windows laptop. Yes, Humphrey. I'll take the last question from Humphrey. Humphrey, can you ask your question, please? There are some questions you have now that when we get into the testimony session, those questions are answered. Humphrey, can you ask your question?
All right. Thank you very much, Prof. This is very interesting. I just want to ask a question concerning the application. I noticed that you concentrated only on Java. And my question is, does it mean that in Devo, we cannot do, take other developers, say like Python, PHP developer and others? And that is one. Secondly, I also noticed that you mentioned Python also. And in the GitHub, is it that the GitHub has to do with a scenario where the application is made into one language? Those are the two questions I need to ask.
Okay, that's a very good question, which I did not dwell on because we have a long way to go in the course. There are over 50 languages that you can build your applications with. Java is just one of 50. We have Java, Python, we have the C family, we have PHP and all of that. So in terms of building applications, there are over 50 languages that you can take advantage of. So for now, don't worry about languages. In Landmark, what we manage generally are applications that are developed using Java and other languages, but you are going to be generally assigned to Java-based applications. So that's it. We have a testimony session starting from 10 o'clock. So I want us to have to take some break now for the next 7 minutes. So when we come back, we move into the testimony session. And in that session, it's going to be a 1-hour session. In that session, we are going to still have question and answers, okay? So your question is going to be, okay, whatever question you have, okay, we are going to have those questions answered as well. I see that the video is being recorded. Yes, I think I also forgot to make mention of that. Like, after each class, you have the class video to go through it over and over again. Is it okay? So you don't have any problem. The class videos are available for 3 months, which is 90 days. So you have enough time to go through any video and the videos of any class. You understand what I'm saying? So please take notes. Let me make mention of that fact. So that's it. We'll have 5 minutes break and we'll be back to take testimonies from 10 a.m. And try to connect with your video as much as possible.